How's it going? Today we're going to be creating this cool geometry node shader that changes the material of an object based on a plane intersection. If you want to see how this is done, make sure to stick around and I'll show you. Okay, so to be able to create this effect, we need to use some vectors and the dot product. Basically, every point on this model is represented by a vector. So this point right here, called point P, is represented by a vector like this. And this point right here, there would be a vector coming from the origin going to here. And that's true for any point on this model. So every point is represented by a vector. Now, this plane has a very special vector called a normal vector. Basically what that means is that vector is 90 degrees perpendicular to the face of the plane. My drawing says otherwise, but bear with me. So basically what we want to do is calculate the dot product between these vectors and the normal vector. The dot product basically says if the angle between one of these vectors and the normal vector is less than 90 degrees, it's going to have a positive value. And if the angle between these vectors is more than 90 degrees, this is slightly more than 90 degrees right here, let's say, because it's below the plane and the vector is perpendicular to the plane, the dot product will have a negative value. And if it's in between, right in the middle, it'll have a value of 0, but let's not worry about that right now. So now that we know this, we can say that if we take point represented by a vector and find the dot product of it with the normal vector of the plane, any point on this side of the plane should have a positive dot product, and every point on this side of the plane should have a negative dot product. And that's how we can assign the different materials to the faces of this object. So that's the theory. Let's put it into practice now. Alright, so now that we're in the Geometry Nodes editor, I'm going to select the object of interest and create a new node tree. Okay, so we want one material for each side of this plane, and we want to assign different materials based on where it is relative to the plane. So in the Geometry Nodes tab, I'm going to hit Shift A, set material, and insert two of those, one for each material, and again, Shift A, material. And that's where we can select different materials. So for any positive dot products, I'm going to assign a positive material, and any negative dot products, I'm going to assign a negative material. And these are just materials that I made beforehand. So how are we going to go about calculating the dot product? So first of all, we want to find the normal vector of this plane. Object info. I'm going to select the plane, and now we can extract info from this object. I'm going to set this to relative, so it incorporates translation info of this plane into the geometry nodes. So now we want to extract the normal vector. Transfer attribute. Plug that in as the source, and we're trying to find the normal vector, so we want to select vector and find the nearest points. Alright, so what do we want? We want the normal vector, not just any vector. If you take a normal node, plug that into what attribute we're trying to find, the output of this transfer attribute node will give us the normal vector of the plane, which is great, exactly what we wanted. Now, we want to find the dot product of the normal vector. There's actually a node for the dot product. If you retrieve a vector math node, vector math, and set that to dot product, perfect. We want the vector positions of all these points. I'm going to do Shift A one more time, position. And this will give us the position of all the points on the geometry. Blender actually represents points as vectors, so this position node will output a vector. Now we find the dot product of a point and the normal vector, we should yield a value between -1 and 1 out of this. So now we want to set the positive material. The dot product is greater than 0, and a negative value if the dot product is less than 0. So that's pretty easy. Shift A math node, we can create a greater than node and a less than node. Plug the values into each of these nodes, and now any value that's greater than 0 will pass through this node, and any value that's less than 0 will pass through this node. You just need to make sure to set the threshold to 0. So this is a Boolean operation, so if any value goes through here, that's positive, it will select the positive material. If any value goes through here, it will select the negative material, and there we go. It looks like it's working. However, there is one problem. The line where the material changes doesn't move with the intersection of the plane. And why is that? Let's say we have a point here on the geometry. This should be purple because it's under the plane. But what's going on here? So remember, a vector doesn't have a position in space, it only has a direction and magnitude. If I compare this to where the normal vector is, even though the normal vector is here, the angle between them is still less than 90 degrees. What we want to find is the angle between the normal vector and the position vector relative to the normal plane. But how do we find this angle as compared to this angle? What we can do is we can take the translation vector of the plane and subtract that from the global position vector for any point. Let's say I have a position vector to a point and the translation vector of the plane. I can subtract the translation vector of the plane from the position vector, and that will create a new vector like so. And if you notice, this vector is the vector we want, the relative offset of the position vector from the plane. And now the angle between the normal vector and the relative position vector is greater than 90, and therefore it will be purple because the dot product will be negative now. So let's try this. I'm going to take the position vector, Shift A, vector, math, plug that in to the first input, subtract. Now that I have the position vector plugged in, I'm going to subtract the location or the translation vector of the plane. And voila, there we go. It works. And no matter how I move this, it will always intersect nicely. I can scale the plane up and down, I can rotate it, I can move it. One last touch, you may notice that the intersection is quite blocky. That's only because the resolution of the model is quite low. You won't have this problem on higher resolution models. So what you can do is you can add a modifier such as subdivision surface. Make sure to add that before. And I'm not going to increase in the viewport, but I will for the renderer. So now if you render it, the lines should be cleaner. If they're still not clean, just increase the resolution even more. And that's all there is. If you found this useful or just straight up enjoyed it, make sure to subscribe to catch more content like this in the future. I'll be linking a high resolution image of the node tree in the description if you want to check that out. Anyways, that's all from me. Peace.